Let's get started. Thanks for being here. Happy Tuesday. I've got two announcements for you today. One of which there's a retreat that's sponsored by the Mission and Ministry Center. Let me see. Do I have that document? Yes, I do. So there's a retreat on the theme is Finding Your North, which is clarifying your aspirations in life, your finding your vocation. I've been on retreats like this with the MMC when I was a student, and I always found them very helpful and informative and relaxing. It's a weekend away at St. Joseph's Camp by the Russian River. Beautiful place. Highly recommend it. It's happening this weekend. If you're available, registration is $45. There's also, I guarantee you, time to study because it's right before midterms. But yeah, so I recommend that. If you can't pay the fee, there's financial assistance. So there's that too. If you're interested, I can forward you along the emails if you've got questions. Or you could Google St. Mary's MMC retreat. The other announcement I've got for you is a book scholarship, which is brought to you by the Intercultural Center. It's $250 for textbooks, either in fall or in spring, so once per academic year. Again, I received this scholarship when I was a student, and it's immensely helpful, and now I can go and buy my textbooks. So if you want more information, I can also forward this to you, or you could Google St. Mary's Intercultural Center book scholarship, and you'll get there too. Those are my announcements. Just to remind you, the command line game is due tonight, so make sure to finish that up and submit that. The homework 3 is also assigned, and I can hear arguments on when you want this to be due. Right now, I put it in that it's due Thursday before break, but I can have it due at other times if there is sufficient interest. Let's look through that assignment. That's not it. So we're talking about classes in this subunit. And the goal for this assignment is to go look for some data somewhere. So either you make it up yourself if you have knowledge of like a video game or your favorite TV show or something like that, or maybe a sports team or something. So find some data or know it in your brain and then write it down. And that's one step. So find the data. The second step is to open Eclipse and create classes to handle aspects of that data. So I'm going to go through the ComboLock example. So that's one class that I've decided is going to handle the data of the combination. And so your job is to take the data and say, let's say it's, I've got Pokemon here. So is anyone not familiar with Pokemon? Okay, if everyone's familiar with Pokemon, great. I don't have to explain that. I mean, there's a chance that someone could be. So I'm happy to do that. But so we've got Pokemon, and Pokemon have a type, and they've got a list of moves and so many other things that were added in like later generations. So there's a lot of things that we could like handle with Pokemon. And so your job is to choose some things. So I think my requirement is like at least 5 attributes, maybe in total across the different things of data. Exceptions to these, so I've given numbers here. And so if you have data set of maybe like 20 things, but it makes a lot of sense, then just come talk to me and I'm happy to approve that. So first step, find data. Second step, create classes. And include the UML diagram. We'll talk about that today. And then third, write a script, some driver file to maybe use a scanner to input that data and store it in the classes, and then export to a text file. Here's some information. So I should have probably stayed with the Pokemon theme in the example, but like if I'm processing Marvel superheroes, then all the information, I could print like every single thing I have, but maybe I only want to print, are they good or bad? And so I would print, here's the name of, here's like the superhero name, and then here's their like secret identity name. And then this character is either good or bad or neutral, like choosing a subset of that data to actually print. And then, so 1, find data. 2, write classes. 3, take in the data, create class objects, and then print information. 4 is to write a README, just to practice, so that I know what you did to do the assignment. So that you get READMEs in the labs of, here's instructions for how to do this. Those are a little bit more complicated. I've got some default of, here's who wrote the code. Here's what date I finished the code. Here's how to run it, which can be as simple as click the green play button. Here's some summary of, this is what I chose to model. Here's what data I chose. Here's what classes I wrote. Just you write the code, so then I want you to talk about it. And it does not have to be long. It should be short and succinct and very simple. And so then I've got a rubric here for how the points are divvied out. So this I'm considering assigned as of today. I think it should be fairly straightforward. You just have to find some data that is interesting to you, then make classes for it, and then go on from there. Does anybody have any questions?
How are we supposed to look for a data set?
Google. There's a lot of data sets. Let me think. So I know Kaggle, Kaggle, has a lot of like CSV data sets. You have had practice in importing CSV data in lab 3 in the end. So you can reference that code if I encourage you to reference that code. There's also, what's it called? Oh, this is what I was thinking of. There's a machine learning repository, which gives you a lot of repository to check just like simple algorithms, but you don't have to use it for machine learning. So like there's Iris, which says like different aspects about iris plants. Maybe don't choose iris, or do if you're really interested in flowers, but I encourage you to find something that really interests you. Other questions? Okay. Okay, so take this home, think about it. Let me know if you have questions next time. Or tomorrow in office hours, 10 to 12. And again, it's currently due Thursday, but talk to me if you want that to be something else. Okay, so my plan is we're going to go over the combination lock example. I'm going to get examples from you. That's one of the questions on the packet. We're hopefully going to speed through the next 20 minutes of the rest of the slides in 4.1 because we have talked about them for the most part. And then today we'll work on lab 4, which is tentatively due this Thursday night. Questions before we go? Okay, let's do it. Let's go back to the ComboLock slides. All right. So remember, we're creating a class for a combination lock. This is one of those kinds that we input one number, input another number, input the third number, and if all of them are right, it opens. So it takes 3 numbers to open, and we input them in succession, and the order of those numbers matters. So if it's if the combination is 1, 2, 3, and we give 3, 2, 1, it's not going to open. The combination should be secret. We can't see it from the outside at all. And it's going to have 3 main operations: open, close, and change combo. And the change combo comes in only if we know the current one, can we change the combination. We can't just change it willy-nilly. If it's 1, 2, 3, we can't just come in and say, it's 4, 5, 6 now. You're good. Don't ask any questions. We have to know the original in order to change it. Okay, so let's make a class. And it's not gonna. There, now it's autofilled. So you may have the combo lock from last time. Maybe pull this up. And if what I type is significantly different from yours, then I would advise maybe opening up a new class and copying down. Okay, I've got my combo lock. So the first question is, how do I represent the combination? Something you did, I saw. So some of you had the combination as an array, which makes sense. Like we can have 3 numbers. Sounds great. The way I have in my notes is just 3 numbers as int. So if you had an array, that's fine. But the example that I'll go through is with the 3 numbers. So first thing, the combination has to be secret. So I should add private in front of all of these. I'm going to show you. Okay, I always forget the combination. So what I want to do is I want to say private in front of each of these, but I don't want to type private 3 times. So if I go to edit and then toggle block selection, which on my computer, it's Option Command A. So let's try that. Option Command A. Oh. And then it's like zoomed out, but I can select with my cursor across the 3 lines. And now I think this is so cool. I can just type private for all of them. And there we go. So again, that lives under edit and then toggle block selection. So now to get out of it, Option Command A, and we're back where we were. Does anybody know what the command is for Windows? I'm guessing something like Control. Say that again. Alt Shift, maybe if I spell correctly. Yeah, so it usually says it's like next to it what it is. Okay, that's my tangent of just something that can make your life easier. No. I'm just going over the example we did last time, just so that we're all clear on how to do it. So one of the things that I saw in what you submitted is, and like getting started, it's hard to know how we're going to get this input. So a lot of you tried setting up with a scanner. And this is where I would say no scanners, because we are making a ComboLock class, a ComboLock type, and we're going to assume that we're getting the input somehow. We don't know how. It could come from a CSV file. It could come from just me typing the numbers in the main. It could come from a scanner. But I'm not going to prescribe how we should get this information. I'm just going to assume that I get it. And the way that I get it is through parameters. Okay, so let's make our constructor. And again, it may be slightly different from how you did it if you used an array. But I'm going to get the 3 numbers just as parameters when I am creating the combination lock. So I've got these 3 variables. They're named the same thing as my fields, but that's okay. I know how to reference my fields versus the parameters. Exactly. So I can say this dot n1 and just assign each of them. So like the first number is the first secret number, the second is the second, third is the third. Okay, so this dot n1 equals n1. And you'll notice that they turn different colors when I type them. And that just helps you visually to see that they're 2 different things. So this dot n1 is blue, that's the field. Just regular n1 is brown, that's the parameter. Okay. In mine, I also have a Boolean is open. You may have this or not. That just keeps track of what's the state of the lock. Is it open or closed? So this is where I get to make a decision. When I create a lock and I set the combination, do I want it to be open or do I want it to be closed? Do you have an idea? I mean, there's 2 answers, and neither of them are wrong. Yeah, it does like it doesn't matter. So in my notes, I said I want to start with a closed lock. That's the assumption that I made. And maybe when I create it, I can print out just for clarity's sake. I'm going to print, I've created the lock, here's the passcode. And so that's actually, no, I don't want to do this. I want to do printf because that's easier. So where all the numbers are integers. And the numbers are this dot n1, this dot n2, this dot n3. So just printing, hey, you've made a lock, here's the passcode. Again, if you don't have this print statement, that's fine. This is just what I decided I would like to print when I create the lock. All right, that's my 3-parameter constructor. I would also like, so we've got the otherwise here. So I've set the combination in the constructor. It's secret because the variables are private. Now I have to have a case for otherwise. And so I could do this dot n1 equals this dot n2, this dot n3. I'm about to erase this, just so you know. I could say this to set them all equal to 0. That's an option. However, and then I could say like this dot is open equals false, but I've already got a constructor to do all that work for me. I don't want to copy paste code. I just want to call the code that I already know how to do. So I can do that. I can call my own constructor with this. Remember, this is referencing our current object, and our current object has a constructor that takes 3 parameters. So I can call this of 0, 0, 0 to call the ComboLock constructor. Just give it 0, 0, 0. That way it does all the other things that I also want it to do. And that makes this very simple. We like simple code. Okay, so that's ComboLock for the constructors. Now I've got a question for you. Does it make sense for me to go, now that I've got my field set up and my constructors, does it make sense for me to go to source and then generate getters and setters and just select all of them? What do you think? Who thinks yes, it is a good idea? Who thinks no, it is not a good idea? No input on either of them. Okay, so let's say I did do it. What then? I can call ComboLock.get n1. Does that violate my specifications? Or are we okay? Yeah,
Well, is us getting N1 tell us what it is.
yes,
So I'm assuming we should do that if it's like you want to keep your code private.
yeah. It doesn't make sense for me to like this. Maybe this is an analogy of like writing the combination like in Sharpie on the side of it. Then like, what's the point of the lock? So I would say no. And it also for set, like, oh, now we can just randomly set the second number, or like we could set the whole thing to just be whatever we want. And now we have full control over the lock. I don't think that makes sense. So this is an example where, in fact, no, we do not want getters and setters. The reason is that the combination should remain secret. And how do I want to phrase this? And we want to restrict the way that we change it. I think oh no, I didn't miss bracket. So we want to restrict the way that we change something because in our specifications, we say the combination can change only if you know the current one. So we don't want the power to just say the second number in the combination is now 4. The first number is now 1. We don't want to be able to do that. We don't want to give the user the power to do that. Okay. Let's create the methods. So open and close. And maybe let's put change public void change combo. Let's put it after open. Does someone want to tell me your main idea of how do you open the lock? What's your algorithm to do that? So I'm interested in what sort of information do we need? So what information goes into these parentheses? What's our parameters? And what do we do? What did your group think of last time? Yeah.
We had 6 ints.
Mhm.
3 for the combos and 3 for what you're entering.
Okay, so this is for open?
Yeah.
You had 6 for
Okay.
open? I think
No,
probably for change combo. Yeah, okay. So for open, we need the 3 integers, right? So either if you're representing it as an array, maybe you take in an array, or you could still take in 3 integers. That's the basic idea of we need 3 guesses. Then what do you do to compare them? Either you or another group.
I did it. I set mine to input 1, so like
Mhm.
on in the actual, what's it called?
Yeah, so the variable names might be different.
Yeah. But if input 1 equals num1 and input 2 equals num2 and so on.
Mhm. So the way I reference my n1 is this dot n1 is equal to n1, and this dot n2 is equal to n2, and this dot n3 is equal to n3. Then we're good. Question, do we need ands or could we use ors? We need ands, why?
That way, it guarantees that all 3 of them have to be correct, not just like one or the other.
Exactly. Yeah, all 3 need to be correct in that exact order. So if this is the case, then we can say we have opened the lock. Great job. Maybe we choose to print something. Again, this is optional. Lock is open. And then maybe we have an else case. So this assumes that you didn't get at least one of the numbers right. So maybe we print incorrect combination. Okay, so that's my open. Let me double check my notes, make sure I didn't miss anything. Yeah. There's something else here that I want to mention. There's also something else here that I want to mention, but once we get through everything. Okay. Close should be easy, right? We have a Boolean, like, the question is, do we require the code to close it? No? Yeah, like if you're working with one of these, it doesn't matter. You could hand it an open lock to someone, they know nothing about it, they can just close it. So there we go. Okay, so for change combo, we've got the same kind of idea for open, right? We need the original combination and we need the new combination. So this is where we get, I'll just copy and paste this. So the first 3 numbers, maybe I want to assume are the old one. And the second three numbers are the new one. This is something that, depending on your implementation, maybe you say, like, maybe you said int n1 and then nn1, which is the new n1. Maybe you structure it like that, where you have old 1, new 1, old 2, new 2, old 3, new 3. You could structure it like that, and then your code would look a little bit different. But me, I'm deciding to have one group first and then the other group. And I'll call the new version NN1, just for N for new. NN2, int NN3. So total of 6 parameters. Okay. And then I do the same thing, right? I call this again. I have the same if statement, check that the first 3 are correct. And then I'll copy this. So if the first 3 are correct, then I can say, I wonder if we could do NN1, NN2, NN3. Can we? No. So we can't reassign all of them like this. To call the constructor like that, it has to be in the constructor. So instead we have to do this dot n1 equals our new n1, this dot n2 is our new n2, this dot n3 is our new n3. And then otherwise, they didn't give us the correct ones. So maybe we print something like incorrect combination entered. Let's try again. I didn't change anything. Okay. This is basically what I have in my notes. I've left some things, some comments through here of other things that I could think about. So now that I've made the basics, I want to ask, what else could I do? What did I maybe overlook, or what could I fix in this? It does the basics, but I could do some more. And so what I want to do now is looking for something called boundary cases, or something sometimes called edge cases, where we've got the basics down, but now we're exploring the edges of how could something that I've written not perform in the way that I want it to. So let's stare at the constructor for a second. How could something that the user gives me break it or do something other than what I intend? Any ideas?
So, like string in there, or like put a letter instead of like a number in the thing.
Letter instead of number or string. Yeah, that would give me an error though, and it wouldn't let me, the code wouldn't compile. So what could a user give me that would compile that maybe I'm not thinking of? Negatives? Yeah, that's the first thing that comes to mind, where if I'm looking at this kind of lock, the number is even more restricted from positive numbers, including 0. It's 0 through 39. Those are the options. And so if I wanted to, maybe I have some sort of logic in here to restrict. Like if you gave me a number that's not between 0 and 39, then try it again. So let's say so I'm not going to do it. I'm just want to draw attention to the fact that there's other code that we can write to make this class more tight. Anything else that you may think of? Negative numbers is the main one I always like to ask. Okay. Let's look at open. What's some boundary case for open? Think about the state of the lock.
Like it's already open.
Yeah. So like if I've got a open lock, it doesn't make sense to input the combination. Like that's wasted work. So maybe here, since this is relatively simple, I'll say if this dot is open. You can do this, by the way, with Booleans because is open is just a Boolean variable. And so you can stick it in the parentheses. So you say if this is open, then print lock is already open. And then we don't want to check. So we can just say we're done here and return. Now it's a void return type, so we can't return anything. But we can just say return and that finishes the function. So that's our boundary case for that one. What about for changing the combo? Well, I'll also mention that whether or not it's already closed also applies for close. For if we don't want to close it again if it's already closed. How about for changing the combination? Yeah.
Shouldn't really matter, but like if you're trying to change it to something better than this.
Yeah. Um, yeah, if the new thing is the old thing, then why are you doing this? So maybe if we want to avoid doing that assignment, we could say if this dot n1 equals nn1 and this dot n2 is nn2 for, I think maybe it requires more thought because I think because we need to know. So there's one option to put it right here, but then that disregards the question of whether it gave me, if the combination is 3, 4, 5, and it gave me 1, 2, 3, 3, 4, 5, then that would be a problem because they didn't give me the correct combination in order to switch it. So maybe we move that in here. So if they give me the same exact thing, then I'm just gonna print, what are you doing? And not change anything. Okay, this is pretty much it, what I have for ComboLock. Any questions? Okay. I really like this example because it gives you something to build. And it kind of tests how do you approach something like this. Even though it's like a relatively simple example once you see it all written out. But getting there is the hard part. Okay. All right, so I want to do this quick activity where I would like you, let me see, where's the packet? Okay, let's see where we're at. So we did problem 1, we did problem 2, that's definitions. Problem 3, 4, 5. Okay, so we're at problem 6 in the packet. Write your ideas for what could be modeled with classes. So I want you to take a minute, maybe write some things down, get in your neighbor groups and talk about it, write some things down, and then we'll discuss it. So maybe take, I don't know, 3 minutes, just jot ideas down and talk with your neighbors. The sort of things I'm looking here are, remember we did we did combination lock, that's one. We did seminar classes and professors, so something like that. Like mugs or computers or table. Problem 6 is I want to know what sort of things you think could be modeled by classes and what are think through what would the fields be, the methods, anything special we have to do when we're constructing it. So we've done several examples so far, so I want you to think of more of them. Give you one more minute. Brainstorm, think of all the ideas you can. All right, what are your ideas? What did you come up with? Couldn't think of any? Okay, that's okay. Anybody else come up with some?
It's like a backpack. It's like the also do like, the weight, how many pockets it has. And I'm not sure if it would be a method of the field, but like if the backpack is full. I'll tell like people when you put open and close.
Mm-hmm.
Maybe number of straps.
Yeah, um, yeah. I think the more interesting quality of a backpack would be, so we're like getting all this information about a backpack, but what really matters in a backpack? What's its purpose?
Maybe I like a strange array of books.
Yeah, like the interesting thing about the backpack is the stuff that it's holding. Um, like the contents. So maybe string, I would say more of like a list or an array. And you're gonna have practice with this in
Those
lab
have
before.
different types of objects. So they
Yeah, so this is where it kind of,
Because we have like pencils, books.
yeah, yeah. So this is where it kind of breaks down where we have to like assign some type
Yeah.
of things. We could also say that the we'll talk about this when we get to genericity. We could say it contains type object, which is like the most general type possible, and then we can stick pretty much anything in that list. We could stick books, we could stick pens, computers, whatever. But yeah, so there is some like, since backpack is designed to hold a lot of stuff, we have to, there is some maybe restriction that has to happen. Awesome. I love that. Other ideas you came up with from another group or person?
I did video game character.
Mm-hmm.
Oh. Inventory.
So inventory probably has like the same idea as contents, right? It's got to be some sort of collection structure where we can put everything in. Any ideas for like methods? I guess you have to choose a video game.
Yeah. It's like, you know. In the state like low health where something specific
Mhm.
happens.
Yeah. Let's see. Um, maybe like attack is something that the character can do. Or Heal. Yeah, great. Other ideas? Hopefully, I'm hoping for at least one more. Even if it's not perfect, we can work through it. Any ideas? I'm looking specifically at this half of the room. This can also help you with homework, whatever number, the class's homework. This is basically what it's doing. Oh, you find some data, and then you're saying, okay, if I'm looking at video game characters, then I can say like, oh, this is their name, and so on. Let's say we looked at like superheroes. What sort of things might we keep track of? Yeah.
You said what team they're on,
Mm-hmm.
their powers maybe.
Mm-hmm. Maybe their name or their secret identity. Maybe there are two separate fields, name and secret identity. What sort of stuff would they do? Maybe kind of the same idea from video games. Okay, we're not working on that right now. I will help you later. Okay, so I hope this is helpful for you as you start the homework. If you're still confused, come to office hours and I'll help brainstorm. The idea is we have these things that are going on in real life. We have these kinds of objects, and we want to represent those objects in code. That's the goal. And so that's what this is trying to help us do. Okay. Let's see. So, yeah.
Which of the things that would be there, like, which would be like an instance and which is an attribute?
Instance and attribute. So like, let's say Spider-Man is our video game character. And we've got a variable called SM that represents Spider-Man either as this or superhero. Spider-Man is an instance of one of these classes. And like what team they're on. So like if Spider-Man is on the Avengers, that's an attribute. Or how much health does Spider-Man have? That's an attribute. Other questions? Yeah, so your goal for the homework is to create however many. You can like use a for loop. You don't have to do them all manually. I would not suggest doing them all manually. But yeah, so create those instances and then print interesting information from them. Okay, so we're gonna kind of speed through these things, which we've talked about for the most part. We know that printing an object gives us some state of the state of the object. If we didn't have a toString method, like for ComboLock, whoops, let's go here. Let's actually make a driver for this really quick. ComboLock driver, and I'll give it a main. if I say ComboLock C is new ComboLock and I give it 1, 2, 3, then if I try to print C, just do that. So it prints something. So this is what I gave it in the constructor, right? It prints lock created. Here's the passcode 1, 2, 3. Then it prints the hash code, which we've talked about before, where it says, here's where it lives, the U4.1. Here's what it is. It's a combo lock. And then some hash of the object, some combination of letters and numbers. That's the hash code. In order to get something else, we need to define the toString method. And so we've seen this before as well, where it's a function that looks like, I'll just add this in ComboLock really quick. Public returns string. The method is called toString. And maybe since I don't, so here's something to know. So I just printed, there is a lock. I'm about to delete this and use the Eclipse generated version and show you what they gave. So if I delete that and then I go down to source and generate toString, and I just click generate. This is, here, let's run it and see what it gives me. Gives me this. Is this what I want? No. Why not?
ComboLock tells you everything about them.
Yeah, it tells me everything about the lock, including the combination, and I don't want the combination to be public knowledge. So that's something to know about the automatically generated things, like and again, we saw this with like the getters and setters, where it gives you something. The question is, do you want that? Do you want it from like a data privacy point of view, and also from this is what I want to print whenever I'm querying the state of the object. So this is something that Eclipse knows how to give you something very basic, but you need to customize that based on what you actually want. So I'm gonna undo. There. So now I'm also gonna change what I said in the constructor. That way it prints on a new line. So now said there is a lock. Maybe I want to add it's open or it's closed. But to print something other than that hash code, I need to specify the toString method. And that reports something about the state of the object. So I think we have the idea, so I'm not going to go over the date class. If you're still confused about this, though, I can do that. Okay, so for equality, there's we saw this earlier with house as well, where using equals just compares the hash code, or asterisk for strings, it will work like that. But for other objects, it doesn't. So for strings, equals works, but for everything else, it won't. If we want the equals, if we want to compare two objects, which I think we might, then we need the equals method. And so what that's going to do is that's going to check, are the fields equal? Is this object really equal to another object? And so that's the idea of, for my mug, is it the same color? Is it the same capacity? Does it have the label? Does it have maybe the same contents in it? And then I can say in code, these two objects are identical. So Eclipse also has an automatic version of this. Let me go back to the bottom. So source, And then the option is generate hash code and equals. In VS Code, it's the same process. And so I'll select all of those. There's different options. Let's see. Let's check instance of and see what happens. Where'd it go? Okay, so this gave me two auto-generated methods. One of which is just objects.hash, which kicks it upstairs and does whatever objects does. Equals asks a series of questions. So the first question it asks is this, so my current object, equal to the one that you gave me in the parameter? If that's the case, then they're the same. And we don't need to do anything else. So if you gave me my same object, then obviously it's the same. They're equals. Otherwise, we need to check if the thing you gave me is in fact a combination lock. So I've taken in an object, capital O object. That's the generic way of saying I've given you something, some reference type. I don't know what it is, because theoretically I could try and compare a combination lock with a string. And I mean, they're not the same thing. They're not the same type, not remotely. And so in that case, here I would return false. So it checks that the thing you gave me is in fact a combo lock. Then we have to do something called typecasting, which we've been given some object, obj, and once we get past this point, we're assured, yep, the thing I gave you is a combination lock. So now we have to grab the fields and check them. And so we do that with this, where we say, I've given you an object, but I'm now really sure that this is a combination lock, so I'm going to cast it to a combo lock, and then I can do things with that. So we save that as some variable other, and then we check, like before, are all the fields the same? Anybody have questions on that? So the version that Eclipse gives me for this is fine. If it may differ depending on what you are doing. So the boilerplate here is okay by me, but at a later date, I might decide, no, I need something a little bit more rigorous.
Are we on problem 7?
Yeah, problem 7 is toString. Problem, yeah, the toString method. It's asking what's the name of that method. Problem 8. Equals is no unless you're a string. And then equals. Okay, so I checked some boxes in when I generated the equals methods, you may not have, and so maybe it used get class instead. It's multiple ways to approach the same solution. I think when I did it on VS Code one time, it was like really, really long and complicated, which is fine, but maybe not as efficient. Or maybe not as readable. So again, it will give you the boilerplate for what your IDE thinks is a good way to compare two objects. But if you want anything other than that, then you've got to customize it. We've talked about self-referencing. So if we have to dates, and how do we know from inside the class which one is ours? We use the this keyword to self-reference an object. We did that. The main is how we get things done. So that's the only thing that's going to execute. And that's problem 9, which we've already talked about previously as well, for having a separate class and the driver. So this is why we don't have a main in ComboLock. So we've got one file to have the class and another file to test it. Oh, I had a picture for that. Hmm? Yeah, so because we don't want to risk being able to call those, like if we had a main in ComboLock, we could call those fields directly, and we don't want that to happen. Okay, is that the end? No, it's not. I'm looking at time. We'll see. We'll see. So for static is kind of the sort of thing that we've kind of glossed over this whole time. And now we're finally ready to talk about it. So for our combination lock, we've got 4 fields. We've got numbers 1, 2, and 3, and whether or not it's open. These fields have to have a controlling object. It doesn't make sense to use N1, N2, N3 if we don't have a ComboLock object. So this is static things. Non-static things require a controlling object. So ComboLock is not static. So you don't see static in the ComboLock.java. It's a non-static class. And so to use those things, we require a controlling object. If something is static, that means we don't require a controlling object. We don't need to create a ComboLock driver object in order to run the main. Main is a static method. We can just run it. We don't need to create an object at all. So my example for this, let's see if I can pull up the Lab 3 scanner. So if we look at middle, so we had a static field in middle that now we can look at it and see what was going on, where scanner S equals new scanner system.in. S is a field, which means we can use it throughout the class, where you used it in each of the methods. But the field was static because we don't want to create a middle object. We just want to use it. So this is a static field. And all of these methods are, again, static, because it doesn't make sense to have a middle object that does next enter. It's just scripting. We just want it to be done. So no controlling object required. So static is often used when we're doing scripting type things. Okay, so this is the answer to problem 10. I'll just copy that down. Packages, which we've also, again, talked about. I'm trying this semester to try and give this information to you earlier. And now when we get to the point of actually learning it, hopefully you already know this information. Packages are what we use to organize similar classes. So we've got a package of U4.1, U3IO, U2 more Java, and basics. These are all packages that organize similar groups of code. So like basics has all the stuff we did when we were just getting started. Then we've got like house and street and all of those other things. U3 has our Magna Carta and Secret Garden and just scanner files. So it groups related bits of code together. That's the point of packages. In terms of your file system, if you view your project in your file explorer, then the packages are just folders. Java just calls them packages. And we could restrict the visibility of things in our package. Okay, so we've talked about this before as well, where there's public and private. And if we don't have anything, then it's package visible.
Which problem 9?
Problem 9 is no. And we talk about that in slide 36. Okay, so fields and methods we've seen can have modifiers, visibility modifiers. Classes can also have visibility modifiers.
Problem 10.
Problem 10 was on slide 37. Classes can also have visibility modifiers. So far we've just had public class. But we could make only package visible or private too if we wanted. There's a note here that we could make a class private, but then it can't be a top level class. And we'll talk about what it means to be a top level class later. I think probably after spring break. This is problem 11. So I'm not really interested in the columns. I'm just interested in that first column. These are all the possible visibilities. Which we've talked about. So protected we'll get to when we talk about inheritance. But we've talked about public, private, and no modifier. And so the way that we read this chart is within the class, you can access anything. So you can access directly public things, protected things, no modifier, and private things. Within the package, you can get everything but private things. In a subclass, which we'll talk about for inheritance, anything but package visible. And then world, so basically anywhere outside this class in another package, we can only access public things directly. Okay, I'm revisiting my projection. I'm going to say we're going to do lab 4 on Thursday. So the plan now is we're going to summarize what we all just talked about, and then I'll talk to you about UML diagrams. I came up with slides, and so we'll work on installing those, and then that'll be it for the day. Or if we have time left over, you can start working on the homework, and then I can be here to help. Okay, so the things that we talked about how to make a class. We talked about terminology. What's an object? What's a member, a field, or a method? We talked about whether fields should be public or private. Talked about constructors, why there can be more than one, setters and getters. And we talked about important syntax, like toString, equals, this, main. So hopefully all of these words are starting to make more sense in your brain. If you're still really confused, please come talk to me, because it's important that this is really solid before we move forward with inheritance. Okay, I need to update this. So I don't think these are on Canvas yet. Let me actually fix that really quick. Oh wait, the UML slides? I know that like the slide deck is there, but I don't believe that the updated version is there. Yeah, no, I last modified it on the 10th, so it's not. Let's drop this over here and replace it.
Are we doing that now?
We're about to talk about UML diagrams. Okay, so now this deck should be updated. So now if we go down here and it loads. Now you should be able to see these slides, just to reference. Okay, so I talked about this last class briefly, but I want to formalize it. A UML diagram is a way to visually represent our code. UML means Unified Modeling Language. We're going to use it to visualize the classes that we write. So the way it looks like for us in Java is this is the diagram for what you're going to do in lab 4, where you're going to make some of these things are filled in for you, some of the things you write this. I have updated the slide deck on Canvas. So if you download that new version, you should have these slides. So yeah, so some of the things are going to be given to you in lab 4, mostly for author. And then some of the things in library, you're going to write pretty much the whole thing yourself. So that's the goal. And I'm giving you the diagram to help you know what to do. Question? It's the same, we're currently on, the number goes from 47 to 8 and then 49. So currently I'm on slide 49. I'm going to update as we continue on to inheritance, I'm going to keep updating this slide deck. So if you want the more updated version, just download the new one. Okay, so let's talk about what these look like. So this whole box, that is our class. And you know it's a class because we've got a green C there. Book at the top, that's our class name. That's what we've named it. Up here in this top portion, those are the fields. So like for the book, the fields are going to be the title, the ISBN number, the author, and the date it was published. Then since if this is how you structure it, we're going to have the constructor for book. Usually I put it just at the top, just below the fields, but you could put it wherever you want. And so the order in which you see it here will just change depending on that. And then we've got methods. And so we talked about last time how the methods have this colon and then the type after that, and that's the return type. And then over here on the left, we've got all these shapes with different colors. Those are the visibilities. And this is the chart where for fields, this is what the icon looks like, and this is the visibility. So the red square on all of these, let me go back through here. On all of these, the fields are all red squares, so they're all private. And all of the methods and constructors, those are green circles, and so they're public. Okay, so now I want to use the rest of the class to try and install this. Who here has Windows? Windows, you're in VS Code, Windows. Okay. And then the rest of you with Mac is, and so it's the same process, we just have to do an additional step. Okay, so for VS Code, I don't know of a way that you can get this. So so the alternative to this is to just hand draw it. So if we know what this should look like, if we know like the anatomy of this diagram, then you can draw it by hand, and that's also fine. So hand drawn is also okay.
Oh,
Do you have a question?
so what if we can't memorize it?
If you can't memorize it, I'm not expecting you to memorize it. And so you get this sort of thing by looking at the code that you wrote and then drawing a box and say, here's the fields, here's the constructor, here's the methods. And I can say, like, my fields are type string, author, and local date. You can just see that by looking at the code itself. So you're not inventing the wheel here. You're just taking the information that you wrote in the code and writing it into this diagram. So that's why I say that you could do this by hand if you wanted to. But there's a handy tool that lets us do it. So for Eclipse, the way you get there, this is what it's going to look like. Let's go to Eclipse. So bring this down here. You go to help and then Eclipse Marketplace. And that brings up this pop-up window that for me loads very slowly. And then I'm in the search box. I search for something called plant, then the letters UML. Hit enter.
Right.
No, just plant UML, one word. And then here it is. So for me, it's already installed, but for you, I would click install.
On which one?
The one, yes, that's it. Chances are it's the first one that comes up. So you press install. And then there's probably like licenses and stuff that come up. Just agree to those and continue. Once we get to this, I'll pause for a second. Because then there's other things that Mac users need to do. Yeah. Yes. Okay, let me walk around. Anybody else not seeing it? Text content originating from the following authorities. Select all? Is for yeah, and then trust select. Yeah, okay, so there's I don't want to mess things up, but if I uninstall it. Oh, okay. Hopefully this doesn't mess everything up. It does press confirm, but there's no confirm. Finish. Restart. Okay. I'm uninstalling it to show you what it looks like. Okay, I will be there in a moment. Okay, now install. No license to review. Okay, I think I did that. Okay, yeah, so here's where we got. So I'm going to select all and then trust selected. And then I'll restart. What do you mean? Yeah, so click select all, which is right here. And then trust selected. Then down here, you see it's installing. Select all, and yeah, do this, yeah. And then restart, yes. Okay, does anybody else need help? Okay. So. We've gotten here. Actually, let's try this before I tell you to do something. Select this one, please. Okay, so can someone on Mac? So the way that we see it now is with window, show view, and I think plant UML should be in here. So let me know if it's not. Did you restart? Mhm. Okay, I think it should be in show view. Is Oh, yeah. Other and then, yeah, plant UML, and then just the first one. Maybe. Yeah. So that was other, and then plant UML, and just the very first one. Okay. So if you get there, then something opens to like next to the console or something. And you're on Mac. Can I see what it? Oh my gosh, it works. Does it not work for anybody?
What?
If you can see a picture, then you're good.
I don't. Anyhow.
Okay, so I think we need to do this other thing. Yeah. Double click. First one. Click on the other ones. Right click on. Oh, there we go. Here. What do you need help with?
Okay, what are we doing now? The HP?
Window. Show view. Down to. other. Go to plant UML. The first one. Might take a second. Okay, so if it's working for you on Mac, great. If it's working for you on Windows, did you figure it out? Yeah. Great. Is there anyone else who it's before you're on Mac? Is it just blank?
Yeah, it's blank.
Okay. There's a chance you need another thing. Which we may just run out of time for this one. So it needs something called GraphViz, which for Windows and I think some Macs it's already installed, but for other Macs it's not. So I would like on these slides, or you could just type in like go to brew.sh. That's a website. And then down here is install homebrew. So if you click that and copy it to the clipboard. And then if I go to terminal, then I would paste it. And this installs a package manager called Brew, which you will then do install GraphViz. So, because GraphViz is something that it helps visualize things. And so on Mac, it doesn't come pre-installed, or maybe on some of it, because I think some of it's working. But on others, you have to install it. And so then this is what GraphViz says to, that's how you install it. So installing Brew will take some amount of time. Installing GraphViz will also take some amount of time. So we're out of time now, but I'm happy to stay and kind of walk you through it if you've got the time to.
Mine is still
Sit through.
blank.
Click inside the class, inside the ComboLock. Okay, so
Oh, yeah.
so if you've got it all good, then you're good to go. If you still need to do it, maybe hang around if you can, and I'll get you going on this. Thank you. We'll do lab 4 on Thursday. Make sure your homework is turned in for tonight. And I'll take these packets on Thursday. Oh, great question. For active learning, turn in I would like you, so here I can see ComboLock. I can export it. So if you right click on this and click export, that saves it as an image. Just save it as something and then drop that in to the active learning.
I think we already upload ComboLock.
For the previous one. I want this image. I want this image. Okay, we'll double check with this on, if you have VS Code,
Which
I'll give you points.
just right click on the.
Yeah, right click,
Then
export. Yeah. Save it as whatever file name you want, and then turn that into Canvas.